This lesson, we're going to talk about matrix inverse. Identity matrix is having 1 and 1 diagonally and everything else is 0. So if you have a 2 by 2 matrix, this is the identity matrix. If you have a 3 matrix, diagonally 1, but everything else is 0. So this is how the identity matrix look like. So how are we going to find inverse matrix? Is going to be when you're multiplying matrix and inverse matrix together, then you should be end up getting an identity matrix. So like this, multiplying matrix itself with inverse matrix, it should be giving you 1. In this case, it will be identity matrix, right? Because we're looking at matrix. We're going to use that to see if we can find matrix or verify if they are inverse to each other. In order to do that, the first example we're going to look at it is, this is the matrix A, and this is the identity matrix for 2 by 2 matrix. We wanted to see what we're going to get when we're multiplying those two together. So let's look at the first one. We have matrix A times I. So it'll be 3, -2, 4, -1 times I matrix will be 1, 0, 0, 1, identity matrix. So what are we doing? We're doing A times I first. So when we do that, don't forget we're doing row multiplied by columns. So this will get first row from the first matrix times first columns from the second matrix. So it will be 3 times 1 plus -2 times 0. And second column, second row and first column will be 4 times 1 plus -1 times 0. And this one will be 3 times 0 plus -2 times 1. This is 4 times 0 plus -1 times 1. When you multiply this, you will get 3, because that will be 0. This is all 0 when you're multiplied by 0. And that will be -2 and 4, -1. So I'm going to show you what happened if I multiply identity matrix with A. Right? 1, 0, 0, 1 with 3, -2, 4, -1. If it's just the regular multiplication, we end up getting same value. But when it's a matrix, if order is changed, you will not get the same matrix, and that's what I wanted to show, right? So this one, I'm going to show first. Hold on, that will be the row, right? So first row and first column will give you 1 times 3 plus 0 times 4, which is going to be 1. And then let's do first row and second column will be 1 times -2 plus 0 times -1, which gives you 0, so it will be -2. And then when you have a second row multiplied by first columns, you get 0 times 3 plus 1 times 4, which will be 4. And then when you multiply second row, second columns, you get 0 times negative 2 plus 1 times negative 1, which is going to be negative 1. And this is going to be matrix you're going to get. So as you can see that even though you multiply the same thing but by different order, you will get different matrix system. Example 2, let's look at and see if we can verify if they are inverse to each other. So when they're inverse to each other, what happens? If they're inverse to each other, if you multiply matrix B are inverse to matrix A, when you're multiplying those two, this should be giving you identity matrix if they're inverse to each other. Okay, so let's see if I get identity matrix. So I'm going to try in both directions. So let's see. First, I will do A times B. When I do A times B, let's see, I will get negative 3 plus 4, 1 minus 1, negative 12 plus 12, 4 minus 3. This is going to be 1, 0, 0, 1. So let's try the other way around. Also, 1, 2, 4, 6. When you multiply this, I get negative 3 plus 4, negative 6 plus 6, negative 2 minus 2, 4 plus 3, which is 1, 0, 0, 1. So since both cases I get identity matrix when I multiply, so this is going to be yes, they're inverse. Okay. Let's try B. So this one was 8, right? Let's try B. So I will do A times B first. So I will have 2, 1, 3, 8, and negative 1, 3, 1, negative 2. So I will have negative 2 plus 1, 6 minus 2. This is negative 3 plus 8. This is 9 minus 16. This gives you negative 1, 4, 5, negative 7, which is not identity matrix. So this is, I don't have to check even B times A because this is not identity matrix. So since it's not identity matrix, it's not going to be inverse, not inverse. So that's how you're going to tell if they are inverse to each other, if two matrices are given. Next example, I'm going to see or show you how to find inverse matrix if one matrix is only given. So what I will do, let's start with A. If I multiply matrix with inverse matrix, remember I have to get identity matrix. So if I wanted to write this with the given matrix systems, I will say 2, 4, 1, negative 1 is the A matrix times, I don't know what's inverse matrix yet. So I'm going to use the variable. So I will say, I don't know, X, Y, Z, W, right? we're trying to find matrix that have 4 elements. If they're inverse to each other, this is what I should get, right? So set it as equations and see if we can solve for unknowns. So when we're solving this, we will do the multiplications, right? This is multiplications. So when we're doing multiplication, we're doing row multiplied by columns. So I will get 2 times x plus 4 times z, right? That will give me 1 equation. 2 times x plus 4 times z. That will give me 1, right? 1. I am creating 4 equations. So now the second row, first column will be 1 times x plus negative 1 times z, right? That will give me 1x minus 1z should be equals to 0. The same way I can create the other 2. So it will be 2 times y plus 4 times w, right? So it will be 2 times y plus 4 times w should be 0. And then last one is 1 times y plus negative 1 times w. So I will get 1y minus 1w equals to 1. Once you create our equations, we can solve for x, z, and y and w. This way, we were going to set these 2 together because they have a same variable x, z, and solve for x and then z, and then you're going to set these 2 together to solve for y and w. And we should know how to do that by solving linear equations. So if we try x and z first, this equation I'm going to solve for x, then I will get x equals to z. So I should be able to replace z with x on the first equations. That will give you 6x equals to 1, which is going to be x equals to 1 over 6. It's a x amount is same as z, so your z is going to be also 1 over 6. And then what about y and w, right? So the second equation I'm going to solve for maybe y, right? So then this equals to 1 plus w, and then replace that into the second equation. So I have 2 times 1 plus w plus 4w equals to 0. Open the parentheses. 2 plus 2w plus 4w equals to 0. Combine the like terms and move the number without the variable on the other side. I will get 6w equals to negative 2. When you're dividing both sides by 6, w is equals to negative 2 over 6, which is negative 1/3. And when you're using negative 1/3 to find y value, this is going to be 3 over 3 minus 1/3, so it will be 2/3 for the y values. So this way, I should be able to find my x is 1 over 6, z is 1 over 6, y is 2/3, w is negative 1/3. So this is one way of doing it. But I also wanted to show you how you're going to find the inverse functions using the matrix method. So this is the solution we have. I erased the word because I need the space. So how would we do that by matrix way? Well, we're going to write this matrix with given matrix on one side, the other side as identity matrix. And my goal is flipping it. So I'm going to, with this 2-row and 4 columns matrix, I'm going to try to make this side identity matrix. And whatever it happened on this side, that's going to be inverse matrix. So starting with this way, on the left side, given matrix, right side, identity matrix. By row deductions, I'm going to make, my goal is making this side identity. Whatever this side I get, that will be the inverse matrix. So we'll see. The first thing I will do is row 1. Let's try to make this one 0, right? So let's see. I will switch those 2 rows first because I already have 1 on the first columns, right? This is 1. So I will just switch the row. So I will have 1, negative 1, 0, 1, and then I have 2, 4, 1, 0, right? So that I will have 1 here. Now I'm trying to make this one 0, this one 0. So I will do row 1 times negative 2, and then add it to row 2. That's going to give me negative 2, 2, 0, negative 2, and I have 2, 4, 1, 0 for row 2. And that gives me 0, 6, 1, negative 2. When you're dividing all this by 6, I will get 0, 1, 1 over 6, and negative 1 over 3, right? So I'm going to write this as 0, 1, 1 over 6, and 1 over 3. Now I'm trying to make the new row. So this is going to be new row. And now I'm going to make new row 1, right? New row 1 is going to be row 2, new row 2. Because they are already opposite, right? Remember, this is negative 1 and this is 1. So I will just add those 2. So new row 2 plus row 1. New row 2 is 0, 1, 1, 6, negative 1 third. Row 1 is 1, negative 1, 0, 1. So this gives me 1, this gives me 0. That will be 1 over 6. This is going to be 2 third, right? So that's going to be new row 2, or even solution, not 2, 1. And a solution row, which is going to be 1, 0, 1 over 6, 2 over 3. So this way, remember, my goal was trying to make the left side identical matrix, and I have that. So it means this is going to be my inverse matrix. And we had inverse matrix using the other method, and you see they are same. So either way you're doing it, you should be able to get the inverse matrix. So my inverse matrix is going to be this sign, right? A to the negative 1 exponent. That's the sign of the inverse matrix. Let's try one more using B. We have 1, 0, 1, 2, negative 1, 3, 0, 0. And we're trying to find the inverse matrix. This is 3 by 3, so identity matrix of 3 by 3 will be 1, 0, 0, 0, 1, 0, 0, 0, 1. And my goal is trying to make this side identity matrix, right? Then the other side will be inverse matrix. So the first thing I will do on this one, let's see. Let's see if I can make this 2, 0, right? So I will do negative 2 times row 1 with row 2. That will be negative 2, 0, negative 2, negative 2, 0, 0. Added into row 2 will be 2, negative 2, negative 1, 0, 1, 0. When you're adding them, you get 0, negative 2, negative 3, negative 2, 1, 0. Let's try. So I have 1, 0, 1, 1, 0, 0. And then this is the new row 2, so it will be 0, 0, negative 2, negative 3, negative 2, 1, 0. And then what else I'm going to do? I'm going to make this 1, 0 also. So let's do row 1, multiply by negative 3, and add it into row 3. Row 1 become negative 3, 0, negative 3, negative 3, 0, 0. Row 3 is 3, 0, 0, 0, 0, 1. That gives me 0, 0, negative 3, negative 3, 0, 1. So that will be 0. And then let's divide this by negative 3 to make it 1. 0, 0, 1. That will be 1, 0, and that will be negative 1/3. So that's going to be the solution roll, right? So this is going to be solution roll 3. 1, 1, 0, negative 1/3. Now, I need to make this one and this one disappear, right? And this one is going to be 0, 2. So the next thing I wanted to do in a solution roll 3, let's multiply by 3. So that will be opposite of negative 3, right? And then add it into new row 2. So that gives you 0, 0, 3, 3, 0, negative 1. And then this is going to be 0, negative 2, negative 3, negative 2, 1, 0. When you add them up, will be 0, negative 2, 0. That will be 1, 1, negative 1. Let's divide this by 2. So this negative 2 will be, well, I guess you need to divide by negative 2 to make that one 1, right? So then you get 0, 1, 0, negative 1/2, negative 1/2, and positive 1/2, right? So that gives you the solution roll. So right now my solution roll is 3, already done. And then solution roll 2 is going to be 0, 1, 0, and negative 1/2, negative 1/2, and positive 1/2. Now I also need to make the first roll, this number 1, 0, and look like I can just multiply the solution roll 3 by negative 1 to make it opposite. So it will be 0, 0, negative 1, negative 1, 0, positive 1/3. Added into row 1 will give you 1, 0, 1, 1, 0, 0. When you're adding them up, it will be 1, 0, 0. That will be another 0. That will be 0 and 1/3. So you will get, that's the solution roll 1, right? 1, 0, 0, 0, 0, 1/3. So that is inverse matrix, right? This part right here. This is going to become your inverse matrix. So inverse matrix of the given matrix A is going to be 0, 0, 1/3, negative 1/2, negative 1/2, 1/2, 1, 0, negative 1 there. So when you're multiplying these two matrix, they will give you identity matrix because they are inverse to each other. If I try one more, let's do C. I have 2, 4, 3, 6 as a matrix A. Finding an inverse matrix. First thing I wanted to do is dividing the first row 1 by 2. So row 1, let's divide that by 2. Then I get 1 here, right? That will be 2 and 1/2 and 0. And I have 3, 6, 0, 1. And I'm going to multiply row 1 times negative 3 and add it into row 2, right? So then negative 3, negative 6, that will makes it negative 3 over 2 and 0, and 3, 6, 0, 1. I get both 0. No matter what number I get, I will get negative 3 over 2 and 1 here. So I end up getting both 0. And remember, I have to get 1 and 1 here. 1 and 1 here. But I didn't get 1 on the second column. I got 0. So since I have both 0, this means there will be no inverse matrix. If the variable cancel out or will not be able to get diagonally 1, then there will be no inverse matrix. And this is examples of how to find the inverse matrix.